Okay, today is day 58. We just finished up our quiz on minerals, and today we're going to be doing a lab where we identify the three rock types. And we have a little worksheet to do first in order to review what those three rock types are. The first kind is igneous. And we have two types of igneous rocks. One is intrusive. Now, intrusive is when lava cools while it's still in the ground, under the ground. And since it's under the ground, it cools very, very slowly, and that allows large crystals to grow before everything is solid. So you can actually see these large crystals in the rock. The other kind of igneous rock is extrusive. And an extrusive rock is made when the lava has exited the ground, and it cools very quickly when it comes in contact with the air or with water if it happens to be under the ocean. Since it cools very quickly, only small crystals can form before it solidifies into a rock. And once again, igneous rocks form from either lava or magma. Remember that lava and magma are the exact same material. It's just different names depending upon where it's found. Lava is found above ground, and if the melted rock is underground, it's called magma. I might have used those terms incorrectly a moment ago when I discussed intrusive and extrusive, but please remember that lava is above ground, magma is below ground. And these igneous rocks form when this hot melted rock cools and solidifies. Okay, the next kind of rock is sedimentary. Sedimentary rocks form from two different sources, smaller pieces of rock and organic remains. So smaller pieces of rock would be things like sand, gravel that's put together, dust, all sorts of tiny little weathered materials, or organic remains. They could be shells, bones, plant material. When all these little tiny pieces of organic remains or tiny pieces of older rock come together, sometimes they get in a situation where they are compacted together. Compaction means squeezed together. And then they go through cementation. Cementation is when they're actually kind of glued together by sort of like cement. And that naturally is occurring. And as things get squeezed and are in the right environment, they get stuck together in a larger rock, and we call that a sedimentary rock. The third kind of rock is called metamorphic. There are two kinds of metamorphic rock: foliated, which means striped, and unfoliated, which means unstriped. I've also seen this word as non-foliated. We're going to accept either word in this class. Please be willing to look at either one of those words in multiple choice or true-false matching kind of questions. Unfoliated and non-foliated mean the same thing. Okay, these metamorphic rocks are made from pre-existing rocks. But these are pre-existing rocks that are heated up to high degrees or lots and lots of pressure deep inside the earth, and they get changed. The heat allows them to reform crystals, and so the appearance will change, and things look a little bit more blended. The crystal structure is not as defined as before.
I need one more washer.
And let's see here. We will be looking at some samples in our lab today. You'll be looking at them with the magnifying glasses. and trying to make as many observations as possible and making a hypothesis as to whether or not the rock is going to be the igneous with large crystals that we can see, or is it a sedimentary rock where we can see things glued together, sort of, or metamorphic rocks where things are much more blended together. The crystals are not as visible. The colors are not as distinct. This is an art more than a science. It is very tricky to come up with the exact right answers here. We're going to have you guys give it a try, but do not get frustrated by this. When I was taking a geology class in college, I remember being very frustrated by not being able to identify these rocks correctly. I would go up to the teacher's assistant and the professor, and I'd say, gee, I think that this material is this kind of a rock, but the answer key says that I'm wrong. Would you please tell me why I am wrong? And I remember distinctly the teacher's assistant looking at me and saying, well, I can't really tell you why you're wrong. It's just that this is the right answer over here. So anyway, we're going to just do our best here and see what we can see. Here we have one of the samples, and I don't know which letter this is. On the table, you will have all these things labeled, but we can see little speckles of different colors of rock in there, and they're all jagged, and they have all different sorts of sizes and shapes. It looks like they're glued together. And so this would be a sedimentary rock where things have been undergoing cementation. And then we have this kind of a rock. Let's get up closer to it. And you can see the crystals in there, different colors of crystals. And so this would make it more of an igneous rock, one that took a long time to cool because it has such large crystals. You can look at those with your magnifying glass to get more detail. In this one, we have the same colors, but we see that the colors are more blended together. They are not in such rectangular cubic shapes, each individual color. They're more smeared out, and so that would make this more of a metamorphic rock. If you look closely with some high-tech magnifying glasses, you may be able to see crystals in there that are different than the igneous rock crystals. And then we have something like this, which almost looks like black glass. This would be where it cooled very quickly, and so the crystals are so small you can't even see them. Okay, with that kind of experience, would you please look at the samples in the middle island and make your observations on the sheet, and that will take up the time for the rest of the period.